Next point of difference regarding the anomalous significance of anomalous behavior of fluorines is that, yes, due to this point number 8, because of exclusive reaction of HF, fluorine compounds are called superhalogens, whereas the other halogens are not called as superhalogens. 10th point, the halide of silver, that is AgF, it is soluble in water, whereas AgCl, AgBr and AgI are insoluble in water. They are insoluble in water because they are crystalline precipitates, and because of this they have very low solubility product. They have very low solubility product. Point number 11, fluorine cannot form many number of oxyacids. Only available is HOF, whereas H whereas other oxohalides HOX, HOX3 are available, where X is Cl, Bri. All this is due to the non-availability of vacant d orbitals. Next, reaction with water. When fluorine reacts with water, you have the formation of ozone, whereas other halogens, when reacting with water, cannot form ozone. Next point, fluorides are more stable comparing to the current compared to chlorine and iodine compounds. For example, UF6 is stable salt of uranium. So UCl6 is unstable. Then next important 14th point is, fluoride ion has a greater tendency to form complex ions. Fluoride ions has great tendency to form complex ions. For example, there are ions like AlF6 3 minus, okay, FeF6 3 minus, such kind of ions, such kind of ions, such kind of the same similar kind of ions, not possible. These kind of complex ions are not possible. That is complex ion not possible. And last beautiful point of difference is, it's a wonderful point, you'll appreciate it. Due to the absence of vacant d orbital in the valence shell, fluoride cannot form, fluoride ion cannot form polyhalide ions, whereas the other halides can form polyhalides ions like Cl3 minus, Br3 minus, I3 minus, I 5 minus, all these things. Therefore, children, I have given you plenty of points related to anomalous characteristics of fluorine, fluorine related compounds, and the other halogens.